In this video segment, I'm going to demonstrate how to run a simple OLS regression in Stata. We'll be using data that's similar to data we looked at in prior videos. This is data from the ECLSK. It has test scores for students at the start of kindergarten, test scores for students at the end of kindergarten. It has indicators for whether a student's teacher has a master's degree, a doctorate degree, a specialist degree, a bachelor's degree, and so forth. And I also included an indicator for whether the student is white or non-white. So let's begin. We're going to move to our do file editor as before. Again, this is just the place where we type in our Stata code. And I'm going to introduce the command for running a regression in Stata. Now, intuitively, the command is simply regress. So I'll type the word regress, and then I'll include my dependent variable. So that's the outcome or the variable we wish to predict. I'll include my independent variable. That's the variable we want to use to predict the dependent variable. And then I'll include any control variables that I want to control for in my regression model. So let's put that into practice. Say I want to predict test scores, math test scores, at the end of the kindergarten year. I would begin with my regress command. I'd find the variable for math test score at the end of kindergarten and put that in the place where dependent variable goes. And then say I'm interested in predicting that test score based on the type of degree that the teacher has. So I'll include 4 different independent variables for whether a teacher has a master's degree, a bachelor's degree plus a few extra years of education, a specialist degree, or a doctorate degree. Notice that in the sense that we're using categorical variables, there has to be at least one omitted variable. So in this regression, all of my teacher education degree variables are going to be compared to just having a bachelor's degree. So that'll be the omitted variable. You notice I don't include that one in my list of independent variables. Alright, so I've set it up. I've got the regress command, dependent variable, and a series of independent variables. Let's go ahead and highlight that command and run it in Stata and see what we get. Alright, so this is the output of a regression in Stata. So notice the dependent variable listed right here, and each of the independent variables listed below it along with a predicted regression coefficient, a standard error, and a p-value indicating the statistical significance of that coefficient. We notice right off the bat that both master's degree and bachelor's plus some education are negative in the prediction, so they predict a lower test score at the end of kindergarten, and they're both statistically significant as indicated by these p-values of less than 0.05. I'll also point you in this output to the r-squared value, which is shown in the upper right. So we notice from this regression that very little of the variance in the outcome is explained by this model. And that's not actually that surprising. We wouldn't think that simply knowing whether your teacher has a master's or a doctorate would be all that informative about your achievement at the end of kindergarten. Well, let's go back and add an extra variable to this model that may help us with the r-squared. So I'll copy that same command again, but this time I'm also going to include an indicator for the student's achievement at the start of kindergarten. You can kind of think of this as a pre-test score. So I'll add this as a control variable at the end of my regress command. And I'll highlight the command, run this in Stata, and we'll move to our output window. So we see the output looks similar, except this time around I've got an extra variable listed as a control variable. Now you notice this is a highly significant variable, so indicated with a p-value of less than 0.05. And having a higher achievement score at the fall of kindergarten predicts a higher achievement score at the end of kindergarten, as we might expect. We notice as we go to the r-squared as well that the r-squared is much higher now. So we're explaining almost 70% of the variance in our outcome variable. And this makes sense, right? We often say that the best predictor of future performance is past performance. And so knowing something about a student's achievement at the start of kindergarten is going to tell us a whole lot about his or her achievement at the end of kindergarten. We will notice, however, that the coefficient on master's degree is still negative and still statistically significant, as indicated by the coefficient and p-value on that variable. Alright, so I could continue building up this model, right? I could copy this command and say, well, maybe I'm also interested in controlling for whether the student is white or not. So I'd simply add the variable for whether a student is white or not at the end of my regress command and again run this code. And I'd get similar output, again this time controlling for some aspect of student race. Now before we leave regression, I do want to point out one little abbreviation that you may see in other people's code and that you may want to use to save yourself some time. I introduced the command as regress, but you'll often see people use simply reg. Now, Stata has a quick shortcut which allows you to type only as much of a command as you need for Stata to recognize that command. So there's no other command in Stata that begins with reg, so as long as I type reg, Stata knows that I'm trying to use the regress command. You'll often see people use regressions by typing reg, then their dependent, independent variables, and control variables. This will have the exact same effect in Stata as if I had typed the entire regress command, but it saves me a few keystrokes and perhaps makes my code a little bit shorter for those reading it. Alright, so in this video we learned how to run a simple regression and OLS regression in Stata. We introduced the regress command, which could also be abbreviated with reg. We saw that after that we put the dependent or outcome variable, followed by any independent variables of interest, and any control variables. Alright, so using these basic skills, you should be able to run simple OLS regressions in Stata. You should be able to get coefficients and interpret their statistical significance based on their p-value, and see the r-squared or the variance explained by the model. I hope this video is helpful for you as you continue working on regressions in Stata, and I thank you for your time in watching it.